All right, law of cosines. Now, on a triangle, if you're given angle, angle, side, or angle, side, angle, or side, side, angle, it's the law of sines. But what if you're given side, side, side? To do law of sines, you need opposites, right? And this would be like 10, 12, and 14. It's the sine of the angle over its opposite side. Do we have any angles there? No. No, there are no angles, so they have to use, instead, the law of cosines. And then if we have side angle side, where we have 10, 12, and 67 degrees. Okay? If this is 10, 67, and 12, do we have any opposites here? No. So both side, side, side and side angle side have to use the law of cosines. Now, what is the law of cosines? Well, it's kind of related to the Pythagorean theorem in a way. Okay? So, the law of cosines. If you're looking for A squared equals B squared plus C squared minus 2BC cosine of alpha. That's if you're looking for A. If you're looking for B, then B squared equals A squared plus C squared minus 2AC cosine of beta. And if you're looking for C, C squared equals A squared plus B squared, Pythagorean theorem, minus 2AB cosine of gamma. All right, so if you're looking for a side, that'll be easier with the law of cosines than if you're given side, side, side. So we'll do the side angle side first. Okay, we'll do a side angle side first, then we'll do a side, side, side. So let's say that I know this side is 10, this side's 12, this is 67, this is alpha, let's just say this is beta, this is gamma. Okay? So, if I have side angle side, okay, what am I looking for? Well, I'm looking for side B, alpha and gamma. What I want to do is, since I know these, I want to find side B first. So I'm going to use this middle law of cosines. So B squared equals A squared plus C squared minus 2AC cosine of beta. So B squared equals A squared, what's A? 12 squared plus 10 squared minus 2 times 12 times 10 cosine of 67 degrees. You can type this straight into your calculator that way. So I'd go 12 squared plus 10 squared minus 2 times 12 times 10 cosine of 67 degrees. And I hit enter. Now, do you think that side's going to be 150.2 long? No, that's way too big. because that's what b squared is. B squared is 150.2. I want to know what b is, so what do we do to each side? Square root each side. So b equals second square root of the answer, 12.25, or 12.3 in this case. Okay? Now, you can use the law of cosines to figure out this angle and this angle, but you really don't have to. Once you get all three sides in one angle, you can just use law of sines. It's quicker to use law of sines to figure out this angle and this angle. Okay? So if we go the sine of 67 over 12.3 equals the sine of alpha over 12. Now, doing this, if I go 12 sine of 67 equals divided by 12.3 equals, and I get a decimal, so it's inverse sine of the answer. I get 63.9. Should I take 180 minus that to see what my obtuse angle is? Not in this triangle, we don't have to, because we know all three sides. And we know right now, looking at this, 67 is opposite the biggest side, right? So there's no way this can be an obtuse angle. Okay? So we're stuck at 63.9. Well, if I have two angles, which add up to 130.9, this angle must be 49.1. And now I found every angle, every side. Okay? So those are the easy ones when you're looking for a side. Just plug it into the law of cosines. Remember to take the square root. And then do the law of sines after that. Okay? Not too hard. Where there's more difficulty is when you have a triangle with law of cosines. So if this is 16 and 21 and 18, alpha, beta, gamma. Let's just put them down like that. Okay, you told alpha, or A is 21, B is 18, C is 16. Now what do we do? Okay, you say, well, which angle should I find first? Always, always, always. So law of sines works out as a second step. Always find the biggest angle first. So the side opposite, the angle opposite the longest side, find that first. Okay? So I'm going to look for alpha. So alpha is with A. So I'm going to use the A squared equals B squared plus C squared minus 2BC cosine of alpha formula. Okay? Alpha goes with A. So if alpha is on this side, A is alone on that side. If you're looking for B and beta, you'd be cosine of beta here, and then B squared over here. All right. So you put in the numbers that you know. Well, I know A is 21 because it's opposite of alpha. B is 18 because it's opposite of beta. And C is 16 because it's opposite gamma. Minus 2 times 18 times 16 cosine of alpha. So 21 squared equals 18 squared plus 16 squared minus 2 times 18 times 16 cosine of alpha. Now, how do we solve that? What are we trying to get alone? Trying to get alpha all alone in the end. Okay? So 21 squared, kind of a big number. 441, I bet, yeah. And 18 squared is 324. 16 squared is 256. I know that one by heart. And then 2 times 18 times 16 is 576. Cosine of alpha. So can I take 324 plus 256 minus 567? Because 324 plus 256 I know is 0. Carry the 1. 8. It's 580 minus 576 cosine of alpha. Can I just take 580 minus 576 to get 4 cosine of alpha? The answer is no. Because can you take 4 equals 5 plus 7x and just add the 5 and the 7 when you're solving an algebra equation? No, you can't. So you have to subtract 580 from each side. Okay? 580, so it's 441 minus 580 is negative 139 equals negative 576 cosine of alpha. Divide by a negative 576. Cosine of alpha equals 0.2413. So do the inverse cosine of the answer, second cosine, second answer, and you get 76 degrees. 76, yep, 0.0 degrees. All right. Then if you want, you could do law of cosines to figure out this and subtract from 180 to figure out this. Or once you have 76, you can just use law of sines. The sine of 76 over its opposite side, 21, equals the sine of beta over 18. And then just use law of sines to figure out the next part. So the 18 sine of 76 divided by 21, second sine, second answer, 56.3. And then to figure out gamma, it's 180 minus 56.3 minus 76, which is 47.7. So, side is a little bit more difficult, takes a little more time. Okay? All right. So you'll start with a side angle side problem. So let's do this one quick. A is 8, C is 6, B is 98.9. Okay? First step, Eli Oaks, what do we do?
Find the longest side.
Nope. Nope, don't have to find loss.
Do the law of cosine.
Do the law of cosines right away. What variable is going to be alone on one side? Which law of cosines am I going to use? A squared equals B squared plus C squared? Or B squared? Because B is alone on this side. So B squared, because B is what I'm looking for. B squared equals A squared plus C squared minus 2 AC cosine of beta. Okay. So b squared equals 8 squared plus 6 squared minus 2 times 8 times 6 cosine of 98.9. So you take 8 squared plus 6 squared minus 2 times 8 times 6 cosine of 98.9. So b squared is 114.85. So what is b? There you go, second square root of the answer, and it's 10.7. Once you get that, then how do you find the angles? Law of sines. Law of sines. So you go the sine of what you're given, 98.9 over its opposite side, 10.7. And it says 4 decimal places for this, 10.7169. Why do they say 4 decimal places instead of just 1 decimal place like the other ones? Because when you're rounding in the middle of a problem to find other angles, if you round too little, you could say, that could throw your answer off with the signs. Okay, it can make a big difference in your answers. So let's do the sine of alpha. Nope, they want the sine of gamma. So we'll do the sine of gamma over c. So cross multiply. 6 sine of 98.9 divided by 10.7169. And then we'll do the inverse sine of that. So, second, well, I don't need to do that yet. So we go 6 times the sine of 98.9 divided by 10.7169, and then go second sine of the answer. Boom. 33.6. So then you go 180 minus 33.6 minus 98.9. And you get 47.5. Okay? Just a few steps to get that. Okay? This is a side, side, side. So 21.9, 15.6, 16.7. Which angle do I want to find first? Alpha. Not just because it's listed first here, but because it's across from the biggest side. So since it's across from the biggest side, we find it first. I don't need that up right now. Oh, and then I closed it instead of minimized it. Oh, well. Okay. So since I'm looking for alpha, I use the a squared one. A squared equals b squared plus c squared minus 2bc cosine of alpha. So 21.9 squared equals 15.6 squared plus 16.7 squared minus 2 times 15.6 times 16.7 cosine of alpha. All right. So 21.9 squared is that. Now, can I just subtract 15.6 squared and 16.7 squared right off the bat here? Because if they're on this side and I square them and add them up, I'm going to eventually subtract them from 21.9, aren't I? So if I do it as one step right at the start, I go 21.9 squared minus 15.6 squared minus 16.7 squared. All is one step. I get negative 42.64 equals, and then multiply these together, 2 times 15.6 times 16.7 is negative 521.04 cosine of alpha. So if we divide by 521.04, whoops, forgot to put on the negative there. So it's 0.0818, and then second cosine of the answer is 85.3. Okay? And then you just do law of sines to figure out gamma or beta. So the sine of 85.3 over 21.9 equals the sine of beta over its opposite side, 15.6. So 15.6 times the sine of 85.3 and then divided by 21.9, and then second sine, second answer gives me that angle, 45.22. This one was 85.3. Round to one decimal place, 45.2. Those add up to 130.5, so this must be 49.5. All right. So you have a couple more of those. And then it says, determine the number of triangles with the given parts. So you have a side of 6, a side of 4, and a side of 1. Okay? How many triangles can have those parts? Well, if it's side, 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 how many triangles can be 6, 4, and 1? Well, they're just 1. Because it's side, side, side. Okay? Determine the number of triangles like this. Well, if you draw it out, and you got 110 up here, 30 here, and 60 here, how many triangles can you have like that? Think a little harder on this one. 0. Why, Andrew Comas? Can't have one. Because it's over 180 degrees. Oh, and I screwed this up now. There we go. 0. 0. Now, you got another one. And I know this is a lot smaller than 179 degrees, but I'm just doing it to make a point here. Alpha is 179. It's 16 on one side and 1 on the other. Why do you say 0? What?
Could you have like an angle that's 0.5?
You could, yeah. You could have a 0.1 for an angle. So here you got to do law of cosines to see if it works or not. And if it does, if everything works out, then there's one triangle because you can only have one obtuse angle in a triangle. So here, on this one, C is 4. It's opposite of a 45-degree angle. B is 11. So let's make beta there, gamma there, alpha here. Okay. Is this side angle side? No. Is it side, side, side? No. It's side to side angle. Okay. So then you have to use the law of sines and see if you can do an obtuse angle like from the last assignment. Just figure out if there's 0, 1, or 2 triangles. Okay? All right. Then we'll get to a problem like this where an engineer wants to position 3 pipes next to each other like this. This pipe has a radius of 2.9. This one has a radius of 4.2. This one has a radius of 5.2. So how far apart are the centers of each of those pipes? Okay, what's the length of each side of this? Well, how can I find the length of AC? Because if it's 2.9 here, it's 2.9 here. If it's 5.2 here, it's 5.2 here. If it's 4.2 here, it's 4.2 here. So if you add this side is 8.1. This side is 7.1. And this side is 9.4. And you do law of cosines to figure out each angle. Law of cosines, and then you can figure out law of sines, but I would figure out angle C first because it's opposite the longest side. Okay? And I think that one, yeah. So a skater skates along a straight path from points A to B. A to B is a straight path. 2 streets that intersect at point C also intersect the path that the skater is skating along. So C is down here somewhere. Intersects those. Okay? AC is 0.4. BC is 1.3. Angle C is 107. How do we find how far the skater skated? Side angle side. You can figure that out. Okay? So there's 10 questions. It'll take you a little while to get through these 10 questions. And then if you have any questions,